Hey everyone, this is video 272. We are reaching a new topic here. We're going to be talking about lenses and mirrors. But first, I want to just briefly discuss the types of images that are going to be produced by lenses and mirrors. So the first thing that we learned in a previous chapter is that light always reflects off your object. So you can consider your object to be a source of light. So the incoming rays, so when I'm saying incoming, is the ones that are going to be going towards the lens or mirror that we're going to be talking about. They're going to come from the object and then they're going to refract through a lens if you have a lens. And the image is going to be formed where the rays intersect. So this picture here is showing you the lens of your eye and then showing you those rays that are refracting and intersecting here. And so they're forming an image on your retina. The image is upside down in this case, but your brain can process it and you see the objects upright. So when we're going to be looking at lenses and mirrors, there are two different types of images that are going to be formed. The first type is called a real image. This is what you're used to. So real images are formed where the light rays converge. So you can see in this lens here, very similar to before, you've got all of your rays of light are originating from this object, and we're often going to represent our object as an arrow. Then they're refracting, they're bending through this lens here, and they're all intersecting at this point, so that's where your image is going to be formed. So we say that the rays actually pass through this image because they're actually intersecting at that point. So that's how you know that a real image has been formed. What you might not be familiar with is your virtual images. I'm sure you've looked at yourself in a flat mirror here. And what you see when you look at yourself or any object in a mirror, in a flat mirror, is a virtual image. So what you see here, for example, you have your object right here. You've got some rays of light originating from that object here and reflecting into your eyes. We'll talk about how these images are formed in the next section. But you can see that none of these rays of light are meeting up together, right? They're all converging. They're all diverging. They're not converging and meeting up at a point. So what happens is that these rays of light appear to diverge, right? If you just trace them backwards, that's what your eye does. It traces those rays back until they actually do converge. And that's where it's going to see the image. So we say that this is a virtual image because the rays don't actually intersect at this point. The rays appear to diverge from that point. There's no light that is actually passing through this image. So right now I'm actually going to show you the difference between a real and virtual image with my setup that I have here. What I have here is an object. It's just an LED light that has an F shape. And then here is my lens. This is a convex lens. You can see the shape of it, the way it's rounded. Convex lenses form real images. And this is just a screen. It's just a piece of plastic. And I'm going to capture my image on this screen. So what I've done here is I have placed my object 30 centimeters from the lens. The lens actually has a focal length of 10 centimeters. We'll actually see this in a problem later. And then I'm going to look at the screen here. You can see that there's kind of a very blurry little green blob here. What this means is that the image is not being formed at this exact location because it's very blurry. So what we want to do is we want to try to find where is that image actually created. And if you look at that screen, as I move it a little bit closer, now you can see, look, there it is, a very clear F upside down. That means the image is created at this location. This is actually 15 centimeters from the lens. You can see if I move it a little bit, it becomes blurry, and now it's clear again. But it's clear right here, but then look, it's blurry again. So depending on where you place the object in relationship to the lens will definitely affect where that image is created. But anyway, the point is that this is a real image. We can capture it on the screen here. Now I want to show you a virtual image. I don't want you to think that virtual images don't exist. They do exist. You just cannot capture them on screen. So what I'm going to do is I'm going to replace my convex lens with a concave lens. You can see the curvature of this one. It's kind of like a cosmetic mirror, right? It curves in like this, but it's a lens. So I place this in here. And concave lenses do not form real images, they form virtual images. You can see on my screen now, there's no image, right? I can't capture it. There's no image here. So what does this mean? Well, the only way to see the image produced by a concave lens is to actually look through the lens. So what you can do here, I'll just put this object right here, it's this box, right? See how big it is? If I put the lens in front of it, you're looking through that lens, and now you can see the image of the object. You know that what you're seeing is not the actual object, because the object is this big. You're seeing an image. As you move it a little bit further away, you can see that image gets a lot smaller. As you move it closer, the image gets bigger. The real object is right here, though. So this is the difference between real and virtual images. Real images you can capture on a screen. A virtual image, you cannot. You've got to look through the lens. Now, the only exception to this is if you form a virtual image and then use another lens to make a real image out of that virtual image. But we'll save that for another day.